Hello everyone. This is an A-level revision video of a series where I discuss past papers and model questions every week to prep for exams. Many of these questions are relevant for high school maths qualifications around the world like AP and HSC. For detailed explanation, I have made topic-based theory and question videos. You can check them out on my channel. Question number 1. Part A, you have to express sin x plus 2 cos x in the form r sin x plus alpha, where r and alpha are constants. R is positive and alpha acute. Let's see how you can write this expression in this form. Take sin x plus 2 cos x equal to r sin x plus alpha. Now aim is to find this constant r and alpha. How you can find it? You have to expand right hand side, then compare coefficient of sin x and coefficient of cos x. That would give you two equations of r and alpha. When you solve that two equation, you would find r and alpha. Let's do that. If you expand right hand side, you would get r sin x cos alpha plus r cos x sin alpha. Compare coefficient of sin x both sides, you would get 1 equal to r cos alpha. Take this equation as equation 1. Now compare coefficient of cos x both sides, that would give you 2 equal to r sin alpha. Take it as equation 2. You can eliminate r if you divide equation 2 by equation 1. That would give you tan alpha. Tan alpha equal to 2, therefore you can find alpha equal to tan inverse 2. You can use the calculator to find that value. You have to give alpha in radian to 3 decimal places, 1.107 in radian. To find r, you can eliminate sin alpha and cos alpha. You can find r if you eliminate alpha from these two equations. Take square to equation 1 and square to equation 2, then add those two equations together. You would get 2 square plus 1 square equal to r square sin square alpha plus r square cos square alpha. Take r square out. Left hand side we have 5. Sin square alpha plus cos square alpha equal to 1. So we have r square equal to 5. Therefore you can write r as square root 5. We take only positive value because we know that r positive. Now you can write sin x plus 2 cos x in this form. R is square root 5. Alpha is equal to 1.107. So you can write sin x plus 2 cos x equal to square root 5 sin x plus 1.107. Now you have modeling question here. Centigrade theta is the room temperature on a given day, modeled by this equation. Variable t is the number of hours after midnight. T varies between 0 and 24. Always in modeling question, you have to pay attention for definition of these variable. So here we have definition for theta and variable t. So what they ask, using the equation of model and your answer to part A, you have to find the maximum temperature of the room during this day. Take the model equation, theta equal to. You can see we have same expression as here. According to this expression, if you take x as 5t over 12 minus 3, now you can write theta as 5 plus square root 5 sin 5t over 12 minus 3 plus 1.107. According to this expression, theta varies because of this sine function here. Therefore, theta would get maximum value when this function, sine function, get maximum value? We know that maximum value for this sine function is 1. Therefore, you can write theta as 5 plus square root 5 times 1. Therefore, maximum temperature equal to 5 plus square root 5 centigrade. Part C, they ask you to find the time of a day when the maximum temperature occurs. You have to give your answer to nearest minute. What they ask, we need to find T when theta is maximum. We know that temperature theta maximum when this function equal to 1. So we can write sine 5t over 12 minus 3 plus 1.107 should be equal to 1 when theta maximize. Now you can solve this equation for t. Pi t over 12 minus 3 plus 1.107 should be equal to sine inverse 1. So on the left hand side you would get 5t over 12 minus 1.893 equal to sine inverse 1 is 5 over 2. You can solve this equation, make t as a subject. You can use the calculator. You would get t as 13.23 in hours. They ask answer to nearest minute, so you would get t equal 13 hours and 14 minutes. Question number 2. Let's see what you got here. Circle C has equation x square plus y square. Therefore, we can see the center of C is 0, 0 and the radius of this circle is square root 100, that is 10. So we can put this information on the diagram. Coordinate at O is 0, 0 and radius of circle C is 10. So we can draw this line here. This length should be 10. And circle C2 has equation x minus 15 square plus y square equal to 40. Therefore, this circle C2 has center 15, 0 and radius is square root 40. So we can put this information here. The center is 15, 0 and radius is square root 40. Circles meet at point A and B. Part A, they ask you to show that angle AOB, this angle AOB, we have to show this angle as 0.635 in radian. You can see in the diagram, x-axis is symmetrical line. Therefore, if I take this angle as alpha and this angle also alpha, so AOB angle is 2 alpha. If you can find alpha, then we know angle AOB. Here we have right angle triangle. Therefore, if you know this length, you can use sine ratio to find this angle. If you know coordinate at this point, you can find this length, which is y coordinate at this intersection point. Therefore, first you have to solve equation of this circle and equation of this circle simultaneously to get this intersection point. I take this as equation 1 and this as equation 2. To solve that, what I'm going to do, from equation 1 you can make y square as a subject. Now substitute this result into equation 2. Therefore, you can write x minus 15 square plus y square I'm going to replace by 100 minus x square equal to 40. Expand this bracket. This x square cancelling out, that would give you x equal to 285 over 30. If you use the calculator, you would get x as 9.5. If you substitute 9.5 to this equation, you would get y coordinate plus or minus square root 39 over 2. So you can get coordinate at this point as 9.5 comma square root 39 over 2. Therefore, this length should be equal to square root 39 over 2. Therefore, you can write sine alpha equal to square root 39 over 2 divided by 10. To find alpha, take sine inverse of this value. That would give us alpha. You would get alpha in radian as 0.3175. We can write AOB angle now. It's 2 alpha. This is equal to 0.635 radian. Let's see how we can do part B. We have to find the perimeter of the shaded region. What we can do, we have to find this arc length, take it as L1, and you need to find this arc length, take it as L2. Basically, we need to find L1 plus L2. Arc length given by this formula are theta. Theta should be measured in radian. Therefore, we can find L1 equal to R is 10. Theta is this angle here. This angle we can write as 2 phi minus 2 alpha. We found 2 alpha as 0.635. Therefore, we can find L1. L1 equal to 10 times 2 pi minus 0.635. Use the calculator, you would get L1 as 56.5. To find L2, this arc length, we need to know this angle. How we can find that angle? We can find that angle if you know this angle here. So you can take this angle as beta and this is beta. So if you know beta, we can find this angle which is 2 beta. So this whole angle going to be 2 pi minus 2 beta. If you take this right angle triangle here, you can write sine beta as this length divided by square root 40. Here we have a right angle triangle and we know this height is square root 39 over 2. Therefore, we can write sine ratio for this small triangle here. You can write sine beta equal to square root of 39 over 2 divided by square root 40. Beta is sine inverse of this value. Beta equal to 0.516. So 2 beta equal to 1.032 radian. Using this formula, you can find L2. Using this formula, you can find this length L2. L2 equal to R is now square root 40 times theta is 2 pi minus 2 beta. We found 2 beta, substitute it here. So total perimeter equal to L1 plus L2, that's equal to 89.7. In this question, you have to use this substitution x equal u square plus 1 to show that this integral equal to this integral, where p and q are positive constant. You need to find those constant. Let's see how you can do this. When you use substitution to find integral, you have to change this function of x into function of u, and you need to convert dx into du. Essentially, you need to find limit of x as limit of u. You can do those one by one. I'm going to take this integral as I. Take the substitution x equal u square plus 1. Now differentiate this with respect to u. You can write dx equal to 2u times du. Now let's find this pq limits. Take the substitution again. Substitute x equal 5 to find p. This gives us u as plus or minus 2, but we have to take positive value. Therefore, lower limit u equal to positive 2. Substitute x equal 10 to find the upper limit. And this gives us u as plus or minus 3, but we have to take the positive value, that's 3. Now you have to convert this function of x as function of u. X equal to u square plus 1. Therefore, we can write x minus 1 as u square. If you take square root both sides, you can take square root of x minus 1 equal to u. Therefore, you can write integral I equal to 2 to 3. You have 3 dx. Dx equal to 2u du over x minus 1 equal to u square, and we have 3 plus 2 times the square root x minus 1, that is u. You can cancel out one u here. That gives us 2 to 3, 6 du over u times 3 plus 2u. This is the required result. It's same as here, p equal to 2 and q equal to 3. Part B, hence using algebraic integration, show that this integral equal to ln a, where a is a rational constant, you need to find that a. What you have to do, you have to find this integral. You can take fraction 6 over u times 3 plus 2u, find the partial fraction of this fraction, then you can easily integrate using ln rule. You can write partial fraction of this as a over u plus b over 3 plus 2u. We can write 6 equal to a times 3 plus 2u plus b times u. If you substitute u equal to 0, you would find a equal to 2, and if you substitute u equal to minus 3 over 2, you would find b as minus 4. Now you can write this integral as we can integrate these two functions one by one, thus 2 ln u minus 4 ln 3 plus 2u over 2. You have to substitute this limit. We can simplify this. Using logarithm rule, you can write inside the bracket as single logarithm. That's ln u square over 3 plus 2u square. We have limits 2 to 3. Substitute limits to the function. This equal to ln 9 over 9 square minus ln 4 over 49. Again, you can write this as a single logarithm. When you simplify this, you would get ln 49 over 36. And you can see a is equal to 49 over 36. I have also made lessons for lower levels. Check them out on my channel. To continue with this series, check the next video. See you in the next one.